1.
All right, so we're going to do a few practice problems. So if everybody would have their periodic table out, and let's practice determining how many protons, electrons, and neutrons are in the following atoms or ions. So pay attention to if there is a charge or not written as a superscript. If you do not see a charge, then you have to assume it's an atom. So if you would pause the video right now, and then after, let's say, about 5 minutes, restart it and then check your answers. I'm going to go ahead and put the answers up here as we go, just for time's sake. So look, if you look at the periodic table, find sodium. Well, we see the atomic number is 11. That means that sodium has 11 protons. Since there's no charge here, you would also say it has 11 electrons, because in an atom, the protons equal the electrons. Now, to get your neutrons, you have to subtract your atomic number from your mass number. So if you look on the periodic table, you remember we said that sodium has 23 is what its mass number would be. Subtract 11, the atomic number, from it. So you should get 12 neutrons in sodium. All right, let's look at iron. Iron's in the center of your periodic table. He's element 26. So that means he has 26 protons. Again, there's no charge here, so he also has 26 electrons. To get your neutrons, you're going to take his mass and round that to 56, and then subtract your atomic number from it. 56 minus 26, so that's going to leave you with 30 neutrons. Moving on, sodium. Here we have a charge. This is a sodium ion. Now remember, your protons can never change, so the protons for sodium, the ion or the atom, are going to still be 11. Protons will never ever change no matter what. When we see a positive 1 charge, that means that sodium has lost 1 electron. Remember, if you lose a bad habit, it's a positive thing. So he's lost 1 electron. So remember, he had 11, he's lost 1, now he has 10. You should have said he had 10 electrons. To get your neutrons, you do it the same way as we did before. Take your mass number, 23, minus your protons, which is 11, and you get 12 neutrons. Here we have the calcium ion. Notice he has a positive 2 charge. Calcium's atomic number is 20, and since he has a plus 2 charge, that means he has lost 2 electrons. So calcium has 18 electrons. To get your number of neutrons, you're going to take the mass number 40 and subtract your protons from it. 40 minus 20 gives you 20 neutrons. Here we have oxygen with a negative 2 charge. We call this the oxide ion. So the atomic number for oxygen is 8. That will never change. Here he has a minus 2 charge. This means he's picked up 2 bad habits. So he's gained 2 bad habits and became negative by 2. So you have to add 2 electrons. So 8 plus 2 gives you 10 electrons. To get your neutrons, you take round the average atomic mass to 16, because it's 15.99. Subtract 8 from it, and you get 8 neutrons. Here we have the fluoride ion, F with a negative 1 charge. So you should have said 9 for the protons. Since he has a negative 1 charge, it has 10 electrons because he gained 1 electron. And to get your neutrons, you're going to take 19 and subtract from that 9. And 19 minus 9 leaves you with 10 neutrons. Okay? Now, we have another term we need to be familiar with. They're called isotopes. Notice here I put emphasis on the prefix iso. That means same. So atoms of the same element, but they have a different mass number. Now remember, the protons in an atom can never change. So that means that if the mass number is changing, it must be the neutrons that are different. They have the same number of protons because that can never change, but they have different numbers of neutrons. Recall that we learned that when you add the protons to the neutrons, that's what is equal to the mass number. So since your protons can never change, the neutrons are what are different. So let's look here and kind of break down the proton, electron, and neutron count in 2 of the isotopes of carbon, carbon-12, which is the most common isotope, and then carbon-14. Carbon-12, if you look on the periodic table, find your protons. He has 6 protons. In this notation that you're looking at, this is called the hyphen notation. That 12 is the mass number rounded to the nearest whole number. So in both of these notations, the number you see after the hyphen is the mass of that particular isotope. Same element, carbon, which means they both have 6 protons. There's no charge here. This is a hyphen, not a negative sign. If it was a charge, it would be written as a superscript. So that means he also has 6 electrons. They both have 6 electrons. The only particle that is different is the number of neutrons. So here, to get your neutrons, you take the mass number. This is 12 for this carbon. You subtract your protons from it. 12 minus 6 is equal to 6. It has 6 neutrons. With the second isotope we see here, we have 14 for the mass number. You subtract your protons, 14 minus 6, and that's going to give you 8 for the neutrons. Notice between these two isotopes, same element, but their mass numbers are different. And the reason that their mass number is different is because if you compare their neutrons, they're different. So since you can have isotopes of atoms, we have 2 methods of representing isotopes. We have the hyphen notation and the nuclear notation. Let's look at the hyphen notation first. When you're using the hyphen notation, you must get the atomic number from your periodic table. So always have that handy. You will see the symbol of the element or the name of the element, and you will see a hyphen. That's where the name comes from. And then after the hyphen comes your mass number. Remember, the mass number is the sum of your protons and your neutrons. So let's practice with 2 isotopes here. We have iron hyphen 56, and we're going to determine the protons, the electrons, and the neutrons. So find iron on the periodic table. He's in the center. Give you a second to find it. So we have 56 for his mass number. And if you look on the periodic table, you'll see 26 is his atomic number. So remember, the atomic number is equal to the protons. So he has 26 protons. Since there's no charge, he also has 26 neutrons. And to get the number of neutrons, you're going to say 56 minus 26 to get your neutrons. So 56 minus 26 is going to give you 30 neutrons. For carbon-14, carbon's atomic number is 6. So he has 6 protons. I have a typo here, right here. It should be 26 electrons, class, sorry. I just saw that. All right, 6 protons for carbon-14. The electrons are going to be 6 electrons as well because it's an atom. And now to get your neutrons, you're going to say 14 minus 6, and that's going to give you 8 neutrons. That's the hyphen notation. The last type of notation is called nuclear notation. Now in nuclear notation, you'll have the symbol for the element written with a superscript if the charge is present, if it's an ion. You'll have the mass number written up top as a superscript on the left-hand side and the atomic number written down bottom as a subscript. So you really don't even need your periodic table for this type of notation. So since the atomic number is down bottom, you can look here to get your protons. You have 26 protons. Now notice this has a charge. It has a +2 charge, which means that this particular element has lost 2 electrons. So to get your electrons, you say 26 minus 2 gives you 24 electrons. And then to get your neutrons, you subtract 56 minus 26, and that gives you 30 neutrons. With aluminum, 13 protons. This has no charge, so it has 13 electrons. And again, to get your neutrons, you subtract 27 minus 13, and you get 14 neutrons. So practice with these, and this will be all for our lesson for today. I'm going to go ahead and give you these answers so that you can check them, but please pause the video and then look at your answers after you've had a few minutes to work on these. Since we have 5 protons, we can identify the element as boron. To get your notation, the top number, you got to add your protons to your neutrons. So that's going to give you 5 plus 7 is 12 neutrons. The atomic number goes down bottom, 5. And since